Today we are going to cover section 2.6, operations in composition. So write down your title, copy down your essential question. How do you combine two functions to form a new function? And we're going to be doing it algebraically and graphically throughout these notes. So you need to make sure that you get an understanding of both. Go and copy your cutout and we'll start once you are ready. Go and pause it. So we're going to be adding, subtracting, multiplying, and dividing functions. Let f and g be two functions with overlapping domains. Then for all x common to both domains, we can define the operation as follows. The notation that you guys used last year in Algebra 1 was this notation here, f of x plus g of x. We are going to be introducing this notation in this class, which is equivalent. So we can add them, we can subtract them, we can multiply them, or we can divide them. But we know that whenever we divide it, your denominator cannot be 0. The domain of the resulting function consists of all the real numbers that are common to the domain of f and g. So whenever you look at the domain of your resulting function, it's going to consist of all the real numbers that are common to the domain of both f and g. So you want to make sure that you are careful with the domain of your answer. But let's go through example number 1. We are going to be adding both functions, but we need to add it graphically. Now, if you guys remember back in Algebra 1 and in Algebra 2, you did it graphically. It's a very quick process. We are going to be doing f plus g of x equals. Now remember that this notation is the same as what you've seen before, which is f of x plus g of x. Now in this case, they do give you both. So this first f of x is 2x plus 2 plus g of x, which is negative x minus 1. And now we can just add them. So that gives me, we can just combine like terms. There's a plus in between. So that gives me x plus 1. And let me copy my notation, which is f plus g of x. Now the same thing happens when we add them. When we add them, we are going to add all the y values for each function. Remember that whenever we talk about f of x and g of x, we're talking about the y values. So these are the y values, and these are the y values that we connect and we make into a graph. So therefore, must start with the furthest on the graph. I'm just going to start with what is the x value for this? 1, 2, 3, 4, 5. Negative 6. At negative 6, I know that the y value for g of x is 5. But I don't know where the y value should be around here. But I don't see it. So therefore, I'm not going to use it. Then for the next one, at negative 5, the y value is 4. But I'm not too sure where the y value is here for f of x. For the next graph, the y value is 3, and the y value for here is, we do see it, so it's negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, and this is 3. And we are going to add them. So 3 plus negative 6 will give me negative 3. Now I'm going to continue with the rest of the points. I do see a point here. This is 2, and this is negative 4. So 2 plus negative 4 will be negative 2. And I'm going to continue doing the same thing. So let me just place my, I'm going to add every single y value. So let's continue on. So we have, the next one is at negative 2, the y value is 1, and the y value is negative 2. So 1 plus negative 2 gives me negative 1. At the next point, at -1, the y value is 0 for both. So 0 plus 0 is 0. On the next one, at 0, the y value is 2 for f of x. The y value is -1 for g of x. So 2 plus -1 is positive 1. For the next one, the y value is 4, and the y value is -2 for g of x. So 4 plus -2 gives me positive 2. For the next one, I still see a point, which is at 6, and the y value here is -3. So 6 plus -3 gives me 3. Now if I try to do the next one, there's no y value for f of x that's visible. So I must stop. So therefore, this is my resulting graph. I'm going to highlight it. And that should match this function here that we added algebraically. So my y-intercept is 1, which is correct. My slope is 1 over 1, and that matches. And let's go and label it. This is f plus g of x. Isn't it great that our algebraic and our graphical representation matches? And ideally, we should be able to copy every single point. So we can do a half will be -1.5 and positive 1.5. This is -1.5 and 3.5 will give us this point. But we're not going to be we're only going to be doing the integer x values. So let's do the same thing for the second one. So do the same thing for the second one. Find the sum. So you're going to find f plus g of x. See what you get algebraically. Do it graphically and see if it matches. Go and pause it and we'll compare our answers afterwards. Go and pause it. Excellent. So now we have f of x plus g of x, where f of x is, so in this case we are adding a quadratic equation plus a linear equation. So the resulting graph should be, if we add the x squares, only 1x squared, only 1x, and that gives me a -5. And I'm going to bring down my notation, f plus g of x. But remember that on your homework, you also need to place your notation and not just your answer. So your notation is going to be a big component of this class, and I do need to be able to see as part of your answer. So now let's go ahead and add them. So now we know that the first point that we can add is this one here, at -3. The y value is 5, and the y value is -4. 5 plus -4 is 1. On the next one, the y value is 0, and the y value is -3. 0 plus -3 is -3. The next one, the y value is -2 and -5 and -3. -2 and -3 gives me -5. On the next point, at 0, the y value is 1 and the y value is -4. 1 plus -4 is -3. So it's this point here, that point here, that point here. Let me just double check. We have, no, this is incorrect, right? There was a point. This is -1 plus -4 is -5. There you go. That makes a little more sense. 1, we have 0 plus -3 is -3. 2, y value is 1 plus 0 is 1. So let me just circle the ones that, this one here, this one here, this one, this one, this one, and this one 0 plus 1 gives me 1. So this one here. Now for the next one, we have 2 and 2, 4, 5 will be 7. So therefore there'll be a parabola, probably this. Notice the symmetry on both sides, so there'll probably be another one 7 over here. So that'll be our graph. And we go and place it in highlight a different color. And if we did it correctly, it should match. Now let's go into Desmo so we can actually graph it, and that way we can see how we can actually graph compositions in Desmos as well. So, and you can do this on the graphing calculator, but just Desmos makes it a little easier. I'm going to graph. I'm not typing. Let's go and check the first one. We have f of x equals 2x plus 2. F of x equals negative x minus 1. Now, when I do the composition, I can actually type in, or the addition, not the composition, but the addition. I can, let's see if this, no, that doesn't work. But I have to do h of x. Let me call this, this was supposed to be g. So I want to call this h of x as the new function will be f of x plus g of x. And if we did it correctly, then we should just be able to type in h of x equals x plus 1. And that matches, right? Now, if we do the second one, where we have f of x will be x to the power of 2 minus 4. That's our parabola that's given to us. G of x is x minus 1. And the answer that we got was x squared plus x minus 5. And if we take it away, we should be able to see the one behind it, and which means that we did a perfect job. And that matches our graph, right? We can actually just check some of the points if we want. We should put point here, point here. We can make a table, but at this point we don't want to be making a table for now. But you notice that that matches here, that matches here as well. We'll come back to Desmos in a few minutes. Now, for example number 2. So go and copy example number 2. Let's work with letter A first, so you have enough space. Pause it, and we'll continue once you're ready. Go and pause it. So example number 2, given f of x and g of x, find f plus g of negative 2. So remember that we need to be able to add both functions. And you need to be able to make a decision whether we have two different options to be able to add them. First, we can actually take the time to add the functions first. So therefore I can add f of x, which is x squared plus 3x minus 5, plus g of x, which is 1 minus x. Then I can simplify it. So it gives me x squared. I can add my x's. That gives me plus 2x and minus 4. And once I have this, then I can actually take the time to plug in my x value. So therefore this will be x squared plus 2x minus 4. And I'm basically just going to plug in the x value, which gives me positive 4 minus 4 minus 4. So that cancels out, so it gives me negative 4. So therefore f plus g of negative 2 is equal to -4. Now, there's another way of doing this. The other way of doing it is just to be able to separate this first. So therefore, we can separate it as f of -2 plus g of -2 and evaluate each one. So therefore, plugging a -2 into the f function, that gives me x squared plus 3x minus 5. And whatever I get, I'm going to add it to my g function, which is 1 minus x, which is -2. So therefore, simplify this gives me 4 minus 6 minus 5 plus, simplify this gives me 1 plus 2. That gives me -2 minus 5 will give me -7 plus 3 will give me -4. So therefore you get to choose. Both of them will give you the same result. Most of you guys will prefer to do it this way, especially if the equations get a little more complex. It'll be much easier to do it this way. So that's how we'll do it for the next one. But either one will give you the same exact answer. So try letter B. You get to choose one way or another. Go and pause it, see what you get, and we'll compare answers afterwards. Excellent. So now I need to be able to subtract them. So I'm just going to rewrite it as f of 3 minus g of 3. And I'm going to plug in a 3 into each one. So it gives me x squared plus 3x minus 5 minus, make sure that I place this in brackets, and g is 1 minus x, and I'm going to plug in a 3. So therefore that gives me 9 plus 9 minus 5 minus parentheses or parentheses 1 minus 3. So that gives me an 18 minus 3 is 13 minus -2. So it gives me positive 15. So therefore f minus g of 3. Now if you had done it the other way, where you subtracting them first, you'll get exactly the same answer. Example number 3. On example number 3, copy it down, go and pause it, and we'll continue once you're ready. So given f of x is equal to the square root of x and g of x equals the square root of x minus 4, we need to be able to find f divided by g of x. And we also need to be able to find the domain. So the actual work is just pretty straightforward. F divided by g of x. That'll be f of x over g of x, correct? And now we can just do a quick substitution. F of x is the square root of x. G of x is the square root of x minus 4. Now we can actually take the time to simplify it, but one of the things that we're learning in calculus is that you actually are going to leave it as this. I'll explain in a second why sometimes we don't want to actually simplify it. This will be the final answer. And now I need to be able to find the domain. So let's go and look at f of x. If we look at f of x, which is equal to the square root of x, what is the domain? Because according to our definition says that the domain of the resulting function consists of all real numbers that are common to the domain of f and g of x. So I need to be able to find the domain of each one and see what's common between both of them. Let me just do a quick number line. Now the question is, do you remember what the domain of the square root of x? Do you remember the shape of the graph? You do. It's supposed to be like this, correct? But you also want to be able to think about it algebraically. So what values can I plug in for x? Can I plug in a 0? Yes. Can I plug in a positive number? Yes. Can I plug in a negative number? No. So therefore your domain starting from 0 all the way to the right. And it's going to include 0, and all the numbers to the right will be your domain. Now let's do the same thing for g of x. G of x equals the square root of x minus 4. So the question is, what is the domain for this function? So the domain for this function are what values can I plug in for x? We know that we have a square root. So what is the smallest value that I can plug in for x? Correct, 4. Correct? If I plug in a 4, 1, 2, 3, 4. If I plug in a 4, gives me 0, and any number greater than 0. Now, what is common between both of them? Common between both of them will be this section here. Do you agree? After 4, they have that in common. So therefore, our domain, now the question is, can I plug in a 4? It will be from 4 to infinity. We know that infinity gets parentheses, but we have to be careful. Even though the domain for this one includes 4, if I plug in 4, 4 minus 4 gives me 0, and the square root of 0 is 0. So therefore, can I have a 0 in the denominator? So that's going to restrict it to an open parenthesis. Now, let's go into decimals, and then I'll explain why sometimes we don't want to simplify it. And I know that's kind of contradictory into what we learned so far. And you'll find that more in calculus. But for now, if I do f of x equals the square root of x, that is the function. Notice that the domain is from 0 all the way to infinity. And we know that it does include the number 0. G of x equals the square root of x minus 4. That is what the graph looks like. And we know it includes 4. Now if we do, let's call the new one h of x as f of x divided by g of x. That is the graph. And notice that there is an asymptote in here, so we never reach 4. And if we want to make sure that we have the correct graph, we can just type in h of x as our answer, just square root of x divided by the square root of x minus 4. Correct? Notice that this gives us the same graph. Now, if I decide to simplify it, if I do decide to simplify it, then I will, let's just simplify underneath, or I'll just simplify it in a separate piece of paper. If I take, we cannot have a square root on the denominator. That's what we've learned so far. So therefore, as part of your answer, if I multiply by the square root of x minus 4, then this can get multiplied as the both square roots. So I can multiply x times x is x squared, x times negative 4 is negative 4x. Denominator, the square roots cancel, so I have x minus 4. And nothing to simplify here. So therefore, if I graph this, and I just type in h of x again, equals the square root of x squared minus 4x divided by x minus 4. Notice that we get the same graph on this side, but then we get this extra graph on the left. So your domain has changed. And that's why sometimes we prefer to leave it as what it was before we actually rationalize it. because at that point, due to this x squared, we are able to plug in negative numbers, so -2 and -1, but we want to be able to leave it as our domain that will be common to both. So that'll take us to example number 5. And actually, if we go back to example number 1, notice that in both cases, we can go back and write down domain will be from -infinity to +infinity, because the domain for A, they both are lines, and that's all real numbers, so therefore they both have that in common. And same thing for B. The domain for the parabola is all real numbers. For the line, it's all real numbers, so therefore that is in common. So for the domain for letter B will also be from -infinity to +infinity. And on this one, we want to be able to leave it as this as your answer, unless the problem says to be able to rationalize the denominator. And that'll take us to example number 4. So take the time to copy down the cutout in example number 4, and we'll continue once you're ready. Go ahead and pause it. So we have the composition of two functions. So we have f of x and g of x. And you guys have seen compositions before in this format, where you read it as f of g of x. We're going to introduce this notation, which is read as f composed with g. So the domain of f composed with g is the set of all x's in the domain of g, such that g of x is the domain of f. And we'll come back to the domain once again on example number 5. So the domain is going to be the domain of g. So it's going to be dominated by g of x, by the domain of g of x. But for now, on example number 1, we have a line, which is 2x plus 5, and we have a parabola. The domain for f of x is all real numbers. The domain for g of x is all real numbers. So therefore, the domain for both functions should be all real numbers as well. So we know that we can actually, f composed with g of x can be written down just like you guys did last time as f of g of x. That means that you're going to plug in the g of x inside the f function. So let me make sure I write small enough that I can fit everything in here. So equals. I'm going to write down the f function first, but instead of the x, I'm going to leave some space so I can write down my g function. So I'm going to set up first 2x plus 5. And instead of the x, I'm going to replace it with g of x, which is 4x squared minus x plus 1. And now I can just simplify. That gives me 8x squared minus 2x plus 2 plus 5. Combine like terms. That gives me 8x squared minus 2x plus 7. And remember that I do need to see your notation as part of your answers. And now we need to be able to find g of f of x. So go and pause it, see if you can set it up, and then we'll work it out together. Pause it. Excellent. So at this point, your setup should be done. That means that we are going to, let me rewrite it, g of f of x. That's how you're familiar with it. So I'm going to plug in my f function inside my g function. Let me make sure I have enough space, so I'm going to move over here. So therefore, I'm going to write down my g function first, but instead of the x's, I'm going to leave some space so I can plug in my f of x. So therefore, it'll be 4x squared minus x plus 1. And instead of my x, and notice that in this case I had two x's, so therefore I'm going to plug it in twice. I'm going to replace it with 2x plus 5. And now I can simplify. Go and simplify, see what you get, and we can compare our answers. You got it? So in this case, when I simplify 2x squared plus 5, that means I need to rewrite it twice and multiply it out. So if I just do it in a separate piece of paper, or on the left hand side, either way, I'm going to multiply 2x plus 5 multiplied by 2x plus 5. So at this point, you should be able to just do it quickly in your head. So that gives me 4x squared. That gives me 10x. That gives me 10x. And that gives me 25. I'm going to combine my like terms. So that gives me 4x squared plus 20x plus 25. Do you remember the name of this trinomial? This is called the perfect square trinomial because it becomes a square once you factor it out. So therefore, we have 4 multiplied by 4x squared plus 20x plus 25. Distribute the negative, so therefore I have negative 2x minus 5 plus 1. I'm going to use my distribute property to multiply this out, so it gives me 16x squared. 4 times 20 is 80x plus 100 minus 2x, and I'm going to combine those two terms, so that gives me a negative 4. And now I can combine like terms, so therefore combine my x's and combine my constants. So we have 16x squared plus 78x plus 96, and the notation is g composed with f of x. Our domain for both of them will be all real numbers. So if we need to be able to find our domain, that'll be from negative infinity all the way to positive infinity. Example number 5. Go and take the time to copy it down, and we'll start once you're ready. Go and pause it. So in this case, I need to be able to find the composition. They give me f of x to be a x squared minus 4. And you should know the shape of this. This is a parabola. And g of x is equal to the square root of x plus 1. And we know the shape of it is square root. So when I find the composition, I need to find the composition A, f composed with g of x, and b, g composed of f of x. And now, in this case, this means that I'm plugging my g function inside my f function. So I'm going to write down my f function first. And I should have enough space in here. So in this case, my f function is x squared minus 4. And I'm going to replace it with g of x, which is the square root of x plus 1. And I'm just going to simplify. So that cancels, so it gives me x plus 1 minus 4, which is x minus 3. So let me write down my notation. It's f composed with g of x. And now I can take the time to find my domain. Now, if we think about the domain for this is a line. Do you agree? But according to this, my domain is going to be restricted by my g of x. So therefore, it's going to be, what is the domain for g of x? What is the smallest value that we can plug in for g? Because that's the value that we actually have in here. So therefore, the domain will be the smallest value that we can plug in for x will be negative 1. It will be from negative 1 all the way to positive infinity. Right? If you plug in a negative 1, can you plug in a negative 1? Yes, that gives you 0. Anything smaller, if you plug in a negative 2, you end up with a negative number inside the square root, so therefore it will be undefined. And if we go into decimals, and just to confirm our domain, now we have f of x to be a square root x squared minus 4. And we know that g of x is equal to the square root of x plus 1. Once we do the composition, and in decimals you actually have to type in as f of g of x. Notice that even though this was supposed to be in line, the composition will stop right here. So it'll be from negative 1 all the way to positive infinity for the domain. So just be careful. So try letter B, see what you get, and then we can compare our answers. So in this case, when we have g of f of x, we are going to plug in the f function inside the g, so therefore that'll be the square root. Instead of x, I'm going to leave it as x squared minus 4. And now I can simplify, so that will give me the square root of x squared minus 3. We have g of f of x. So therefore, what is the domain? That is the question. What values can I plug in for x? Now, if you notice, the domain for g of x, for what we plugged in, it's all real numbers, correct? So that's not going to help us out. So we just need to be able to be concerned are what are the values that I can plug in here. We know that in this case, x squared minus 3 has to be greater than 0. We cannot take the square root of a negative number. So therefore, x squared minus 3 has to be greater than 0, plus 3 on both sides, so x squared is greater than 3. And we can take the square root on both sides, but we have to be careful with the inequality. So take the square root on both sides, so therefore x is plus or minus 3. And even though we want to be able to say that it's greater than, when we actually graph it, we actually have to test a point, just like you guys did last year. So whenever you have an inequality, we have to think about those two values. And let me go into decimal so I can actually demonstrate it. But you've seen this last year when you guys did an inequality. We have x squared minus 3. So what are the values that are greater than 0? So I'm looking at this part of the graph. What are the values that are greater than 0? The values that are greater than 0 are from here all the way up and from here all the way up. So and this is the square root of 3, negative square root of 3, and positive square root of 3. So therefore, the domain, the value that we can plug in is from negative infinity all the way to the square root of 3, to negative square root of 3, union positive square root of 3 all the way to infinity. That'll be the domain. For this part, that'll be the domain. And this will be the answer. Yeah, so just be careful when you're solving quadratic equations with an inequality. It doesn't really translate to this. You actually have to go back into, you have to graph it and then evaluate what are the values that are greater than 0 to be able to determine those two. Example number 6. So take the time to copy it down and we'll start once you're ready. Go and pause it. So in this case, there's two ways that I can calculate this. And for letter A, I'm just going to do it the easier way. We have two functions, f of x and g of x, and they're trying to find out what's f of g of 2. Now remember that you have seen this before as f of g of 2. Now, some people prefer to find the composition first, just like we did on example numbers 4 and 5, and then plug in the 2. But instead, I prefer to do it a little simpler way, plugging the 2 inside the g, and whatever I get, I'm going to plug inside the f. So first, I'm going to calculate g of 2. That means I'm going to plug in the 2 instead of the g, instead of the x on the g function. So it'll be 2x squared minus 5. And I can simplify. 2 squared is 4 times 2 is 8. So therefore g of 2 is equal to 8 minus 5. So therefore g of 2 will be 3. Now that I found g of 2, I'm going to plug inside f. So now I'm going to calculate f of 3. So that gives me negative 3x squared plus 1. But instead of the x will be a 3. And I can simplify. So that gives me 9 times negative 3 will be negative 27 plus 1 will give me negative 26. That is f of 3. So therefore my answer is f composed with g of 2 will be negative 26. Try letter B, see what you get, and then we can compare our answers. So therefore, this means that I'm going to plug in the negative 1 inside the f, and whatever I get, I'm going to plug inside the g. Or if you want to find the composition first, and then plug in a negative 1, you get the same answer. But I prefer to just do it f of negative 1. Plug in a negative 1 instead of the x. That gives you negative 1. Negative 1 squared is 1 times negative 3 is negative 3 plus 1 will give you negative 2. That is f of negative 1. Whatever you get, you're going to plug inside the g. So now we have g of negative 2, which is equal to 2x squared minus 5. That gives me 4 times 2 will be 8, minus 5 will give me 3. So therefore, g of negative 2 is 3, which means that g composed with f of negative 1 is equal to 3. Example number 7. So now we are going to work with the algebraic representation of compositions. So copy example number 7, paste your code, and we'll start once you're ready. Excellent. So in this case, letter A, f minus g of 3. Remember that we can actually rewrite this as f of 3 minus g of 3. So what's f of 3? This is your f function. So if you plug in a 3, you end up with 1, 2, 3, 4, 5 minus g of 3. This is your g function. If you plug in a 3, you end up with 2. So therefore that gives you 3. And make sure that you keep your original notation as part of your answer. What is f plus g of 0? Go ahead and pause it. See what you get. So in this case, f of 0 plus g of 0. F of 0. Plugging in 0 for the f function. If you plug in 0, you end up with negative 1, negative 2, negative 3, negative 4. Plus g of 0 gives you 1. So therefore that gives you negative 3. Make sure to keep the original notation as part of your answer, or you can rewrite it underneath. For letter C, remember that this is the same as f of g of 0. So you're going to take the 0, we're going to plug into the G. Whatever we get, we're going to plug into the F. So first, what is G of 0? G of 0 is, plugging 0 into the G gives you 1. Whatever you get, you're going to plug into the F. So now I need to find F of 1. Plug in a 1 for the F gives you negative 3. So therefore, F composed with G of 0 gives you negative 3. See what you get for D and E, and then we can check your answers. Go and pause it. So in this case, that means that we're going to plug in the 2 inside the F, and whatever we get, we're going to plug inside the G. So first, we need to be able to find F of 2. Plugging a 2 inside the F gives you 0. The Y value is 0. Now, plugging the 0 inside the G for 0 inside the G gives you 1. So therefore, G of F of 2 will be equal to 1. Be sure to keep your notation as part of your answer. And letter E. You're going to plug in the 1 inside the F, and then you're going to plug inside the G. First, F of 1. Plug in a 1 inside the F function. F function is a parabola, so therefore that gives you this point here, which is negative 3. Then you're going to plug inside the G, so G of negative 3. Negative 1, negative 2, negative 3 is here. And notice that there's no graph in here for G. It stops here. So therefore, this is undefined. And I should just write down for the notation. The fact that this becomes undefined, that means that this is also undefined. Now, if we go back to example number 3 or 5, notice that the equation that I give you here, x squared minus 4, that is the parabola that's here. The square root of x plus 1, it's here. So even though the answer that we get back seems to have it's a line and seems to be all real numbers, the domain is from negative 1 all the way to positive infinity. So once we have this notation, and once you're trying to plug in a 1, you still get undefined because we don't have a graph. So this is the algebraic representation, and this is the graphical representation. And the last example for today. We'll take the time to copy it down, and we'll start once you are ready. Go and pause it. Now take the time to read it and highlight the key things. Suppose that a businesswoman invests $1,500 as her fixed cost on a new venture that produces and sells a device for a satellite radio. Such a device costs $100 to manufacture. Write a cost function for the product if X represents the number of devices produced. Assume that the function is linear. So in this case, I need to be able to write a cost function. And whenever you write a cost function, we're going to use C of X for cost. So if she invests $1,500 and every device is going to cost her $100 to produce, what will be the equation in here? Notice that it tells you that it's a linear equation. So which is the one that's going to be changing depending on how many items she produces? Will be 100. So therefore, will be 100 every device that she produced, which will be X, plus her initial investment, which is 1,500. So that is the cost function. Find the revenue function. So the revenue is how much money she's going to be getting back as she sells those items. And she's going to sell them for 125. So revenue function will be R of X. Every device is going to be 125. So it'll be 125X. Now give the profit function for the items A and B. So therefore for C, we need to be able to write a profit function. Now your profit function, how can we determine the profit? You'll be how much money you're getting will be your revenue function minus your cost function. And that'll be the notation that you guys will be seeing if you've seen before as well. So therefore the revenue function, so your profit function is equal to 125x minus 100x plus 1500. And I already made a mistake. What is my mistake? Yes, in this case, I should place this in parentheses so I can distribute the negative. The profit function will be 125x minus 100x minus 1500. So your profit function will be 125. So let me go ahead and add them. So it gives you 25x minus 1500. And now I can just answer the last question. How many items must be produced and sold before the company makes a profit? So we want the profit to be greater than 0, correct? So we wanted the profit to be, this has to be greater than 0. So 25x minus 1500, we want it to be greater than 0, since that's your profit. And then we can just solve it. Minus 1500 on both sides. It gives you 25 is greater than 25x is greater than 1500. Divide by 25 on both sides. So x is greater than every 100 is, in this case I'm just going to use a calculator. It should give you, so I have 1500 divided by 25 will give me 60. So therefore, and this is for letter D. So the business rules must produce, and we have to be greater. It can be more than 60 devices in order for the company to make a profit. So this will conclude the lesson for today. Have a great day, and I'll see you guys next time.